Okay, let's say you have to find the equation for a parabola given its focus and directrix. Well, the first thing you need to realize is that the vertex is halfway between the focus and the directrix. So our directrix is at -2, -2, and the line x equals 6. Okay, so if the vertex is halfway in between, you just take the average of -2 and 6, you get 2, and it keeps that same y coordinates. So my vertex is at +2, -2. Now the next thing I can do is I can just use the fact that any point on the parabola is the same distance from the focus as it is the directrix. So if I have a parabola that looks something like this, okay, I know that some point xy is the same distance from the directrix, and that distance is the x-coordinate of the parabola minus the x-coordinate of the directrix, which is 6. So x minus 6. Distance directrix. And actually, I'm going to worry about the square of it, so I don't have to worry about absolute values. That distance squared would equal x minus 6 squared. I also know that that distance from the focus is the difference in the x-coordinates, which is x minus -2, or +2 squared, plus the difference in the y-coordinates, which is y minus the -2, or +2 squared. But again, I'm going to worry about the square of that. So then I can set those distances equal to each other. So I know that x minus 6, the quantity squared, equals x plus 2, the quantity squared, plus y plus 2, the quantity squared. Now, in order to solve this, I need to FOIL out x minus 6 squared and x plus 2 squared. And if I do that, I get x squared minus 12x plus 36, and x squared plus 4x plus 4. And I actually don't have to worry about the y plus 2 squared. I can just leave it as it is. Okay. Well, now my x squareds cancel out. I can move all my x's over here. I get -16x. I'm going to move my 36 on this side, and I'll get y plus 2, the quantity squared, minus 32. Because 4 minus 36 is a -32. And now I divide by 16, -16. I get x equals -1 over 16 times the quantity y plus 2 squared minus 32 over -16, which actually becomes a +2. Now I can look and see if my vertex still works for that point. So if I plug in an x value of 2, so I plug that in, I get x is 2, subtract 2 from both sides, I'm left with 0 equals -1/16 y plus 2, the quantity squared. And the only way that's possible is if y is -2. So my vertex does work. But now let's say I want to graph this parabola. Okay, well I can do that. Well, I'll make a little table. There's x coordinate and y coordinate. And actually, I know when y is -2, I know that x is a +2. And now, since this goes up and down, I'll check y is -1. Realize that this graph is symmetrical, so x is going to have the same value when y is -1 as when y is -3. And I just plug in y is -1. So -1/16 times -1 plus 2, which is a +1. Again, if I would have used -3 plus 2, it would have been -1. But I'm squaring it, so it doesn't matter. Plus 2. So -1/16 plus 32 over 16, which is 1 and 31 over 16. Or we'll do, we'll just do 31 over 16. So as I go here, notice 31 over 16, not that far. Well, let's use the fact that we know that these distances are equal to our advantage. I'm going to pick a hypotenuse of a right triangle. So I'm going to say a distance of 5. So if I find when the distance from the directrix to a point is 5, well, let's see, x is at 6. So that would mean when x is at positive 1. And if I plug 1 into this equation, I'll get 1 minus 2. So it's a negative 1 equals negative 1/16 times the quantity y plus 2 squared. And then multiply both sides by negative 16. I get 16 equals y plus 2, the quantity squared. So at that point, I can take the square root of both sides and say plus or minus 4 equals y plus 2. And that means y would equal positive 4 minus 2, which is 2, or negative 4 minus 2, which is negative 6. So I know when y is a positive 2, I know that x equals a positive 1. And when y is negative 6, I know that x equals a positive 1. Now that allows me to plot positive 2. So it's going to be boom, boom, boom. You see this distance is 5. This distance is 3 over 4 up, so it's 5. Same thing, this distance is 5, negative 6. And this is 3 over 4 down. And that allows me to give some shape to my parabola. It's going to be a very wide parabola. Okay. And so that's how we find the equation for a parabola given its focus and directrix, and then how we'd plot it. Thank you.